Greetings, math fans. All right, so today's topic is intercepting the pole. Okay, this is Santa Claus's favorite topic because he has to constantly intercept the pole. I guess I'm not supposed to say Santa Claus because that's a religious thing, so we'll just call him non-denominational man. Okay, so let's just sketch this. Just make a quick sketch here. Okay, and what is the pole? We already talked about this already, but the pole is the origin, right? It's right here. So what can you tell me about that? In terms of, let's think of in terms of r or theta. Well, what's the deal? Is it restricted by theta? No, it doesn't really matter. I mean, in fact, theta doesn't even matter here, does it? I just kind of look at it and it's like, well, it doesn't matter if I'm at 45 degrees or 135 or 225 or 315. It doesn't really matter. But what does matter is r equals what? 0. This is huge. R is equal to 0. Got to know that, math fans. All right? So in order to find where it's intercepting the pole, we're going to set R equal to 0. Okay? All right, so let's do that. Let me start out with a new problem here. My first example is going to be R is equal to 5 cosine of 3 theta. And what I want you guys to remember is that the rose has 3 petals. Okay? But it truly has 6 petals, doesn't it? Because it's got 3, but 3 are then overlapping. So one set overlaps. So if I went and did 360 degrees all the way around, the unit circle here, how many times is it really going to hit the pole? Well, right, think of it, it's 3. I'm not sure how this looks, but 1, 2, 3. So it hits it 3 times, but then it goes, does it again, does it again, does it again. So it actually hits it 6 times. All right. So that's important. You know that it's going to hit it 6 times. Well, let's kind of figure out what we have to do here. And here's the work. So let me clear this out so we have a lot of room. So we get R equals R5 cosine of 3 theta. And this is the work, math fans. You are required to show me this work. Okay? First of all, you're going to set 5 cosine of 3 theta equal to 0. Okay, because I'm saying, well, r is 0, so I set it equal to 0. And I divide both sides by 5, and I get cosine of 3 theta is equal to 0. I'm going to write this in red. This is the common mistake. And you guys better not do that. The common mistake is instead of setting equal to 0, you set it, in this case, equal to 5. Okay, but I'm not trying to find out the location of the endpoint. Like, that's how you guys do it when you're trying to graph it. I want to find out where it's equal to 0. So please don't set it equal to 5. It's set equal to 0 when you're trying to find the pole. Set it equal to the length of the petal when you're trying to find the tips of the petal. That makes sense. Okay, so the question now, back at this point here, you're saying cosine of what angle equals 0. Right? Well, isn't it 90 degrees? Isn't the cosine of 90 equal to 0? So I'm going to set that 3 theta equal to 90 degrees. Right? Because it's whatever I'm taking the cosine of, that's got to equal 90. So 3 theta equals 90. And then we divide both sides by 3. And we get theta is equal to 30 degrees. Okay? Does that make sense, everybody? But that's one of my answers. But didn't we say we had six answers for this? We have 6 answers. So here's the deal. Let's go back to this. I'm going to kind of just cursor down here a little bit. I have really cosine of 3 theta is equal to 0. And you guys should remember from a couple chapters ago, back in I don't know, November, or probably sometime in November, is if I have a problem like this, and I would say, well, isn't 3 theta equal to, well, again, I'm saying cosine of what is 0? Well, it's 90 right? But it's also, so 90, it's also down here, 270. And remember, you guys told me there are 6 answers. So remember what we did with this? We added 360 degrees to this. So we got 3 theta is if I add, let me keep moving this down here a little bit. If I add that to 90, I get 450. And 3 theta, if I add that, I get 630, right? So plus 360 here. And remember, I've got 6 answers. So I'm going to add, so here, these are my answers so far. And then I'm going to add another 360 to that. I get 3 theta equals 810 degrees. And I add a 360 to the 630, and I get 990 degrees. Okay, I hope you guys remember that. And then what I'm going to do is I'm going to multiply, or really, think about it, if I divide everything by 3, right, divide each of these by 3, I wind up getting theta is equal to 30 degrees, 90 degrees, 150 degrees, 210 degrees, 270 degrees, and 330 degrees. Oops. And notice, Math Fan, these are all between 0 and 360. Okay, not including 360, but including 0. So there's 6 answers to this problem. All right. Now, here's also a deal. And be careful about this, because I'm going to be picky about it. If I ask you guys to give me the theta, that's what you're going to give me, this stuff right here. If I ask you to give me coordinates, because I'm going to be picky about it. A coordinate, it's important. You guys need to tell me, well, what's R for each of these? Isn't it 0? So 0, 30, 0, 90, 0, 150, 0, 210, 0, 270, and 0, 330. All right, so I'm just going to be a little picky because I want you to give me coordinates. I want to know where it's hitting the pole, a coordinate of where it's hitting the pole. Okay. All right, so let's do one more example here, just to kind of make sure you're good to go. All right, so I have R is equal to 5 sine of 2 theta. Okay, and it's nice. There are 4 petals. So it hits the pole 4 times. So 4 hits to the pole. So what do? I do 5 sine of 2 theta. Let's see where it's equal to 0. So divide by 5. So I get sine of 2 theta equals 0. That's cool. Well, you guys pretty much see it's 2 theta. 2 theta means I know I have double the number of answers, so I actually have 4 answers, which goes completely along with that. 4 hits to the pole. So remember, the question is, the sine of what is 0? And you guys agree it's 0 and 180 degrees. So that means you do 2 theta is equal to 0. 2 theta equals 180. And I know I've doubled the number of answers, so each of these guys I'm going to add 360. So I get 2 theta equals 360. And 2 theta is equal to 540. Divide everything by 2, and I get theta is equal to 0, 90, 180, and 270. Again, everything between 0 and 360. Okay, so my coordinates are R, comma, so 0, comma 0 degrees, 0, comma 90 degrees, 0, comma 180 degrees, and 0, comma 270 degrees. Okay, that's pretty easy. That's where it hits the pole. Now, one more thing before I end this video here. I want you guys to understand what's an x-intercept. Let's keep these points here. What's an x-intercept? Isn't an x-intercept where theta is equal to 0 degrees and 180 degrees? Okay. And what's a y-intercept? Well, isn't that where theta is equal to 90 degrees and 270 degrees? Of course, okay. So really what I want you guys to understand as well is that if I just make a quick polar graph here. and I ask you this point, I'll put it in red. If I ask you this point right here, is that hitting the pole? Is it hitting an x-intercept, or is it hitting? Is it a y-intercept? I want you to understand it's all three. Okay, and a pole. So really, when it hits the pole, that's an x-intercept or a y-intercept. Doesn't that make sense? Because, right, if I said, if I gave you a coordinate and I said 0, comma, I don't know, 0, comma 0 degrees, it's hitting the pole. It's kind of like here, if I gave you a graph like this and I graphed it and I said, where's the x-intercept? You would say, oh, it's right here. And if I said, where's the y-intercept? You'd also say it's right here. So this is the deal. If it's a pole, it's also an x-intercept and a y-intercept. Okay? So if I'm asking you for an x-intercept, you always definitely do a 0 degrees and 180 degrees. Because that's what an x-intercept is. It's it's the 0 degrees and it's 180 degrees. But it's also this point right here. It's also the pole. So keep that in mind. All right? And so that's it. That's a pretty quick lesson here. I just wanted to show you pretty much how to get a pole and just a little information about them. All right? That's it, my fans. Adios. Goodbye.